Hello, I'm Lewis and this is DIY Machines, the channel where I get to share with you step by step how to build your own awesome machines. Today I'm going to be building these large neon effect LED wall signs. I wanted to share with you how you can create one of your own designs with integrated Wi-Fi and Alexa controls. Alexa, turn on neon wall light. Alexa, set neon wall light to 100%. This project is similar to one I published about a year ago, which is how to make these dimmable and portable desktop neon effect LED signs. You'll find a link to that video up here. Now, down in the comments of this video, several people asked how they could scale it up to make a larger version, as if you try to buy these custom made online, they can be quite expensive. So I'll show you how I've achieved that with this large sign here behind me with the faux living wall as a backdrop. On my website, you'll also find several other designs which you can download free of charge to help you get going with some project inspiration of your own, such as this coffee bean one here, which I poured some resin inside of and then set some real coffee beans in it for some interesting added texture. Or there's this football one here, whose frame I 3D printed as opposed to the wooden frame you'll find on the living wall one. As I've already mentioned, this sign is controllable with Alexa thanks to the WLED software running on our ESP8266 here on the reverse of the sign. The entire system runs at just 5 volts, and as sometimes it's easier or more appropriate to control your lights with a physical control, I've included a discrete dimmer here at the bottom of the sign. Of course, you're going to need a few parts if you'd like to build one of these for yourself. You'll need a wood sheet for the backboard and some faux living wall tiles. Later, I'm also going to be adding a wooden frame around the outside of my sign using some low-cost pine from the local builder's yard. You're also going to need a 5-volt power supply and neon effect LED strips, a potentiometer, a power switch and DC barrel connector, 2 MOSFET transistors, a sliding switch and logic level converter, an ESP8266 dev board and some hookup wire. I've provided links to all of these mentioned parts down below this video on Amazon. To connect all of our electrical components together, you have a choice. You can either use a Perma-Proto board and some Wago style connectors to connect everything, Wago style connectors, or use the PCB which I've designed specifically for this project. You'll also find a link to my internationally shipping Etsy store, where you can buy this kit of electronic components. And by popular demand, I'm also selling a few of these kits with the 3D printed parts included. Every purchase of a kit helps to fund my next project. So if you do buy one, thank you for your support. I've already gone ahead and cut down my backboard so it's the same size as a 3x2 grid of these plant tiles. To fix them onto the backboard, I'm going to be using a handheld staple gun. You could also consider using some carefully placed glue or small screws if you prefer. Now that we've finished preparing the backboard, we can start to 3D print the letters which will hold our LED strips. Now I'm going to be printing mine with 3D Jake's Eco PLA in a dark green colour to help it blend into the green foliage on our plant sign when it's not in use. I am going to be making the "You had me at hello" sign for my project. Now I've included some other designs which you can download. You'll find links to all of these in the description down below. Also, please let me know down in the comments below if you'd be interested in seeing me create a second video showing you how to create your own 3D printable designs for this project using the free version of Fusion 360. Now, down in the channel of our letters, you're going to find two different types of holes. The first ones are chamfered, and these are designed for our wood screws. We'll use this to attach the letters to our wooden backboard. The second holes are plain old simple holes. These have been thoughtfully placed where we need to pass our electrical wires through from the LED strips, through the letters, and then through the backboard to our electronics, which we'll go over later on in this video. Lay the letters out across your workpiece and find a spacing which works well for you. We can then use some short self-tapping screws through those countersunk holes to hold the lettering into place. Don't worry too much about fastening it right down flush to the surface, as it's likely that some of the leaves and stems on your fake plants are going to get in the way, and it doesn't matter too much. Now that we've got our letters onto the board, it's quite clear to see that there's a little bit too much foliage for us to see them clearly. So before we move on to the next step, I'm going to take my flush cutters and trim some of the leaves off of the plants. Now that we can see our letters a lot better, let's take our drill and prepare those holes for the wires. Put down a couple of pieces of sacrificial wood, as we'll be driving the drill bit all of the way through out the back of our project. With this part completed, we can now turn our attention to our LEDs. If you take a look at this diagram, you can see how I intended for the LEDs to be cut and laid out. This is so that the ends of these will line up with the holes for our electrical wires. Taking a look at these LEDs, you'll notice some little dark spots. These are where the copper pads are and where we can cut the LEDs. When you cut them with your scissors, try to divide that dark mark as evenly as possible so that we have an equal amount of copper pads on both sides, which we can solder our wires to shortly. Now, I would recommend that you go through and cut all the correct lengths of the LEDs and half insert them into the channels for the letters now. This way, you can be sure you have all of the pieces cut to the right length before we turn on our soldering iron and do our first bit of soldering. When you've finished cutting your lengths of LEDs and checking their fit inside of the letters, we can start doing some of our electrical work. Now, you're going to need to attach a 15cm pair of wires to one end of each LED strip. It doesn't matter which end, but you do need to pay attention to the positive and negative wires. To be able to follow that through this project, I'm going to use some red wire for the positive connections, and you guessed it, black for the negative. They don't have to be these colours, but I strongly recommend that you use two different wire colours, as later when we connect for the positive and negative wires together, it's going to be a lot easier to do. When all of your segments have their wires attached, work your way, poking those wires through the holes, through to the rear side of your sign. This time, you can push the LED neon flex strips all the way down inside of the prints, as we will not be removing them again. Whilst I finish off these LED strips, I'd like to say a massive thank you to all of my patrons and YouTube members who help make projects like this one possible. Thank you. Without your support, I could not keep sharing these projects. If you want to become a patron or YouTube member, you'll receive behind the scenes updates and that warm fuzzy feeling for being super kind. Find out more at patreon.com/DIYmachines or click the join button just below this video. Let's start bringing this nest of our wires together. If you're using separate Wago connectors, go ahead and gather the positive and negative wires together into separate holders for each word. Then use a long wire to link these back to a main pair of Wago connectors Alternatively, for my sign, to connect everything together, I'm going to be using this PCB which I've designed and had fabricated by the folks over at PCBWay. This is actually 7 boards shipped as one. We just need to grab ourselves a small saw and cut through these thick white marks. This will leave us with the 6 boards at the top for distributing the power, and then the main master board here down below. As a determined and curious maker, naturally I spent 2 hours to automate a simple 5-minute job. I went ahead and created some cutting tool paths and a custom jig on my Snapmaker Artisan so that I could perfectly cut out these PCBs. Now, if you decide to buy the kit that I'm making on Etsy, then I will go ahead and cut your PCB on this same jig as well to help make those 2 hours worth my time. Once you've got your board separated, connect all the positive and negative wires from each word to a separate power distribution board, paying close attention to those positive and negative sides of the board. We'll then connect all of these back to the main board a little bit later on. With this completed, we can now start assembling the main brains. If you're not using the PCB I designed for the project, then that's no problem at all. I've gone ahead and created this wiring diagram which you can follow, which will explain to you how you'll need to connect your electronics components. However, if you are using the PCB, then you can follow along with me now. First, we're going to need to flash WLED onto our ESP8266. The easiest way to do this is to connect it to your computer with a USB cable, and then in Chrome, navigate to install.wled.me. From this webpage, you can connect to your microcontroller and then follow the step-by-step guide to install WLED onto your board. Once installation is complete, you'll also be able to configure it to connect to your Wi-Fi network. Take note of the IP address that it's been assigned in your address bar, as we're going to need this later to reconnect to our microcontroller. Because the logic level converter that we're using has a shorter height profile than the ESP8266, we'll solder this to our PCB first. To do this, line up the semicircular cutout on the top of the logic level converter and orientate this where the semicircle markings are on the PCB's outline. You can then flip this over and solder it on from the other side. Position the ESP8266 next, with its USB port facing towards the bottom of the board where the cutout is. Flip this over and solder it again from the other side. Our 2 MOSFET transistors are next. The large silver back should be positioned at the top of the PCB where the thick white line is. Solder both of these into place from the reverse. We can also trim off their excess leg lengths as well. Our slide switch is attached from the rear by first aligning its feet with the 3 pads on the edge of the PCB. We can now 3D print the enclosure to hold our main electronics board. I printed mine in some black PETG and then used some double-sided tape on the reverse to fix it to the back of our backboard. Position it in the center near the bottom, but not too close to the edge, because in a moment we're going to add a frame around the outside of our project, and this will encroach just ever so slightly. Now, our main control board that we started assembling earlier is going to be housed in the enclosure down here. So, next thing we need to do is get some more of the wire that we were using earlier when connecting up the LED strips and use it to create pairs of wires to go between the various power distribution boards back down to this main central point. Once we've got them down here to the enclosure, we can solder them onto the plus and minus connections as marked on your PCB. At this point, we have enough of our circuitry that we can do a slightly cheeky test of our LED circuit. Now, we're going to be doing this using the 5-volt power supply from the ESP8266, and this is only as capable as our USB power supply is. So before we do this, slide your slide switch to the program setting, which will disconnect the 5-volt line from the ESP8266 from the LEDs for just a moment. Once the ESP8266 has powered on and connected to Wi-Fi, navigate to its page using the IP address which you recorded earlier. We can now adjust the first few options we'll need to in WLED. Head to Config Settings, LED Preferences, and then set your LED outputs to PWM white. You can now save these settings. Whilst here, we can also enable the Alexa integration by heading into the Sync Settings and then checking Emulate Alexa Device. You can then choose an invocation name for your project. And then, so we don't overload the circuitry, turn the master brightness slider down till it's somewhere between 2 or 5% of its brightness. At this point, you can then slide the slide switch down to the run position and take a look at the front of your display. You should see all of your LEDs dimly lit. If so, great. We'll carry on and assemble the frame and finish off the electronics. However, if some of your segments haven't lit, or none of them have lit, then troubleshoot your work so far whilst there's less to troubleshoot. Now, I'm going to go over 2 different ways that you could make a frame for your project. The first is going to be using wood, and the second, your 3D printer. Of course, you can create a frame of your own design if you want to. For the wooden frame, I've bought myself some common low-cost pine from the local builder's yard. Its profile measures 45 by 20 millimeters, and along its length I'm going to be adding a rebate using my hand router. This rebate is going to be a little bit wider than the MDF board is in thickness and about 5 millimeters deep. This should be enough that once we've assembled the 4 sides of the frame, the rebate holds the MDF place just enough so that it can't wiggle itself loose. Then, after mitering the corners, I used some wood glue and a band clamp to hold everything together and left it to fully dry overnight. Now that I've left enough time for my glue to sufficiently dry, I'm going to go ahead and cut a notch out in the base of the frame. This is going to measure approximately 100 millimeters in width and 29 millimeters in height. There are many different ways that you could go about removing this notch. As a couple of examples, you could use a wooden saw to make some cuts in the wood and then use a chisel to knock these free. Alternatively, if you have one, you could use a multi-tool. You can then go ahead and 3D print the control panel and use some glue to hold it into this notch. If woodworking isn't your thing, you can also 3D print yourself a frame. This one was printed using 3D Jake's Lumberjake PLA in an off-white real wood infused filament. This one is made from multiple segments, which are simply glued and screwed to one another, encompassing the wooden backboard in the same fashion as the wooden frame. Files to make this frame in increments of 10 centimeters are linked to down below, and as a bonus, This time the control panel comes already integrated directly into our frame. For this football themed frame, I have decided to use some artificial grass as a background. The football itself is too large to print in one piece, so it's made of 5 separate pieces which have been glued together. This is then screwed down and pre-drilled as we did for the previous project. We'll continue fitting out the control panel next, and the following steps are the same if you're using a wooden or the 3D printed frame. Connect 3 wires to the terminals on your potentiometer. They need to be long enough to go from the control panel here back to the main PCB. The other ends of the wires can then be soldered onto your PCB as shown here. We will update the configuration of WLED later on so that we can use this potentiometer to adjust the brightness of your sign. But for now, we'll fit this to the control panel and carry on with the rest of the electronics. Align the protrusion on the potentiometer with the notch in the control panel to help prevent it from spinning around in its slot. You can then secure it with a bolt and add the control knob on top of this. The power switch is simply clicked into place by pushing it in from the front side. And then the DC barrel connector is screwed in from the reverse side, similar to the potentiometer. We can then connect the positive wire from the DC barrel to the black wire of our switch. Don't forget that if you're using heat shrink tubing, you should slip it over one of the wires before soldering them together. If you didn't use heat shrink tubing, then protect the connection with some insulation tape. Following this, the positive wire from the switch is connected to the 5V point on the PCB, and the ground lead from the DC barrel connector goes to the ground point. We can now position the PCB in place and fix it down using some M3x8 bolts. We can then tidy the wires into the channel at the top and bottom of the enclosure before 3D printing the lid itself and securing this with another 4 M3x8 bolts. To help tidy up the wires on the reverse, I used several pieces of tape. Now we need to adjust just one more setting in WLED. This is to allow our potentiometer to affect the brightness of your sign. To do this, open up the configuration pages again and select LED preferences. Scroll down the page and change the last option for button 0 GPIO to analog. Now don't worry if you find that when your brightness slider is turned all the way up and your potentiometer is set to full brightness, that you don't see the LEDs on your sign light up. It probably just means that you need to go back into WLED and ensure that you have the effect solid selected and that the slider for this effect is all the way over to the far right. Now you'll be able to control the brightness with the potentiometer or Alexa. To add your project to Alexa, open up the Alexa app. Press the plus sign here in the top right and then choose to add a new device. Select light and then scroll on down to the bottom and choose other before selecting the Wi-Fi logo. It will then take about a minute or two to look for your project. Once it has been successfully found, you can set up your new device by choosing a location for it inside your smart home. The app will then continue to show you a few commands that you can use to operate your new project. Alexa, turn off the neon wall light. Alexa, turn on neon wall light. Alexa, set neon wall light to 100%. Alexa, set neon wall light to 10%. There we are. That's the overview of how I've set about making these various neon displays. I hope it's inspired you to create some designs of your own perhaps, or if you wanted to, you can download these ones for free and recreate them for yourself. If you've enjoyed this project, then I strongly encourage you to take a look at my desktop neon signs. These little cuties are USB or battery powered, dimmable and customizable as well. There's a separate video showing you how to create your own designs to go on top of the base and electronics which I've already designed for you. Thank you so much for watching my video, and please consider subscribing if you haven't done so. Otherwise, until the next project, do some good and ciao for now. This video has been very kindly sponsored by PCBWay. Now, I've been using their services for several years myself now, and they always deliver. Actually, on the topic of deliveries, I've ordered some PCBs on a Monday morning before and had them on my doorstep by Friday, which is very impressive stuff. There's also the option of ordering your PCBs with this gorgeous matte black finish. Look at that. Head over to PCBWay.com where you can order 5 of your custom PCBs for just $5, and if you're a new customer, they'll give you a $5 coupon as well, effectively making the PCBs free. You just need to pay for the shipping. Thanks again to PCBWay for helping make projects like this possible. To create your own designs using 3D printing, on it you're going to find 6 fingers. Be using some common pine that I got from the yokel